Hello, Twitch, just testing my audio. I want to move my mic. That's interesting. Why is it looking like that? I think we're okay. All right, I am going to start with Ciao, Raphael. Thank you. I'm aware that I'm muted. I'm talking on the phone with someone. I'll be with you shortly. Okay, ciao, Raphael. Thank you for your patience in the chat. The reason I'm on the phone with someone is I decided to ask my mom to observe one of my Twitch streams and give me feedback so I maybe move a little more slowly and explain things to people in a better way. Also, because I thought it just might be fun. So I can hear her and I'll be responding to her, and I'll also be watching chat and responding to you. So this is kind of an experiment that I'm trying, and we will see how it goes. So, introduction. It's a little bit maybe intimidating that the introduction starts with a code example, but I'm actually going to use this example and show how we get from code this that says func, and then there's this weird underscore and ready parentheses colon this dollar sign for some reason label dot text equals quote, and now we have some nice English, hello world, and another quote. Let's first read a quick synopsis of Godot Engine. Godot Engine is a feature-packed, cross-platform game engine to create 2D and 3D games from a unified interface. It provides a comprehensive set of common tools so users can focus on making games without having to reinvent the wheel. Games can be exported in one click to a number of platforms, including the major desktop platforms, Linux, macOS, Windows, as well as mobile, Android, iOS, and web-based HTML5 platforms. Godot is completely free and open source under the permissive MIT license. No strings attached, no royalties, nothing. Users' games are theirs down to the last line of engine code. Godot's development is fully independent and community-driven, empowering users to help shape their engine to match their expectations. It is supported by the Software Freedom Conservancy not-for-profit. And I'm going to make a comment about this, that users can shape the engine to match their expectations. The documentation that I'm reading right now and the version of Godot that I'm using right now is version 3.5, but there is a version 4 that's in beta right now, which means it's not totally perfect, but you can still try it out and use the new features. So, given all of that, let's go back to this hello world code. And let's see how that looks inside of the game engine. This is Godot Project Manager, and I have a few projects present, but I'm going to create a new project, which I'm going to call Hello World. And I'm going to save it in users Eric Anderson workspace /Godot /create folder. What is it not doing? Workspade. Create folder. There we go. Even I make mistakes. Create and edit. So now a bunch of windows pop up, and I'm not going to attempt to explain what all of them are. I will ask, Mom, do you see the Hello World Godot Engine window? Yep, that you see it. I'm going to move over to I'm going to click on 2D scene, and I've now created a scene. I'm going to name it main, and then I'm going to add a child node, and I'm going to search for label, create, and you can see that there's now a label here that I can drag around if I do the move thing. And if I look at something called the inspector, let's go full screen. Makes it a little cleaner. If I look at the inspector, I can see text, and I can type, this is a label, and I spelled it a little bit wrong there. This is a label, and now when I click run, please confirm no main scene has ever been defined. Select one, select current. The engine is helping me out with a step that I forgot. So I'll click select current, and it doesn't seem to be working very well. Oh, I need to save. Scene, save scene. Now scene is saved as a text file, a TSCN, which stands for text scene. Let's now select current, and it does run. And this is the game itself, which doesn't do much yet. Oh, we've got a follow from Doomjaw. Thank you, Doomjaw, for the follow. I'm going to close that and go back to Godot Engine. And I'm actually going to exit full screen. The next thing I'm going to do is attach a script. I click this button, attach node script, language GD script. That's a special language that the creators of Godot invented for use with this game engine, but it's kind of similar to Python, so I find it fairly easy to get used to. I'm going to click create, and if you remember from before, in the documentation it said func ready. This created a script that says func ready and then pass. Pass is just a special word for do nothing, because if I leave this blank, it says error, indented block expected after declaration of ready function. That's probably an extraneous detail. I'm just going to brush past that. What I'm going to do is type this code, label.text equal hello world. I type $label.text equal quote hello world. Save that. Go back to the scene editor, click on main, click run, and now in my game, it might be kind of small and hard to see, but now it says hello world. And this is really powerful because I can have the result of just about any calculation. Like I can say variable x equal 5 plus 5. And then if I remember how to do this, formatted string equals hello world percent I, probably for int, and then actual string. I'm moving faster than I want to be moving. Actual string. I have to declare a variable for formatted string. Equals formatted string percent x. Let's see if the identifier actual string isn't declared in the current scope. That's because I have to type var. Doomjaw says, hey, good evening. Hi, Doomjaw. Thanks for stopping by. I think I did this right now. Let's see if the label.text will now display actual string. So I'm going to click on the play button. Yeah, hello world 10. So things that I write in code show up in the game engine. Now I kind of got into some more details there, but do you have any questions about that? Yes, I'm asking you, Mom. Uh-huh. Okay, $sign is a shorthand for look in the scene and find the node named label. I can rename this to something like my label, and then I would have to change this to my label. In this situation, %s means a formatted string. So let's just say I tried to do it this way. I might write hello world X and then say mylabel.text equals formatted string. And if I type this, what do you think will show up in the game world? Let's take a look. The guess is 10, but no, it didn't show 10. It just shows the English letter X. Because the computer's not smart enough. I told it everything inside of these quotes is English. And it said, okay, I'll just print this as though it's English. But if I write %s, this percent is a special signal that tells the computer, I want you to substitute in something at this position. And then when I have the line actual string equals formatted string %x, I'm saying take x and substitute it for %s. And this time it's going to say 10. So if I press play, it says hello world 10. In this case, the game is pretty basic. The game is only a thing that says hello world and then it displays a number. But to give a better example of what a game can be, I will quit to the project list and let's open up instancing. So I double click on instancing. And in this case, the game is, oh, how did that get up there? I'll fix that later. The game is this set of walls. And if you notice on the left here, there's wall 2, wall 4, wall 1. They're a little out of order, but that's not really important. There are various walls. And if I click with my mouse, sorry, there's text up here, which is actually a label that says balls created 100, but balls present 90, 91, because 9 of them fell off the screen when I created them, but because I accidentally created some of them off to the side. Yeah, if I click it again, we'll lose some more. And actually, I can show you a way I was playing around with this. If I take away the roof by clicking on the roof nodes and cutting them out, then I can click the rerun button. And the question is, if I drop all the balls from right here, will any of them ever escape? Hey, how about this? Nate Codes is rating with a party of 3. Thank you, Nate Codes, for that. Good to see you. How's your day? How was your stream? So far we have 300 balls present, 300 balls created and 300 balls present, so we haven't lost any yet. Maybe if I drop some from a little bit higher up. You can see that some of them bounce up pretty high, but none of them have bounced high enough to get lost yet. And at 2,000 balls, it starts to be the case that it runs a little more slowly. So I don't think I'll add any more than that. What I will point out is that my fancy graph has not one, but two problems now, which is it is off the top of the screen, and that's a problem. But I can go here, and it's my canvas layer, I think is what I called it, and I can I'm trying to move it. Why can't I move it? Maybe it's this one. There it is. So I can move it while the game is running, and it updates in live time. And that, to me, is magical. I can also do things like I can click on ball.tscn, and within ball, there's a sprite, there's a collision shape, and there's a visibility notifier, which is getting kind of technical. But the point to notice is I'm going to change the scale on the sprite to 0.1 and the scale on the collision shape to 0.2. And if I go back to the game now, suddenly the balls are a lot bigger and we've lost a bunch. In fact, I think, well, no, that would be kind of hard. I want to be able to just drag this back and forth and see it update in real time. Nate Code says, hey, Eric. Hey, Nate. Thanks for dropping in. So I'm going to restart this, and maybe now we can see this dynamic of balls getting lost. So it's mostly full now, and if we wait long enough, I bet one or two of these is going to fall off and get lost. There goes one maybe. No, not quite. Nate, how was your stream? Oh, there goes almost. Let's add another 100. Yeah, then we lose some. Balls present 995. There goes another one. There's one almost gone. We can also see what happens if I go to main and hide one of the walls, what happens. So interestingly, I hid the wall from visibility, but the collision shape is still present. So the balls don't fall off. However, if I take this and I cut it, then we lose a bunch of the balls. If I undo, then it comes back. That was kind of quick, but you see we lost almost 500 of them there when I took the floor out, which makes sense. One little chore I can do here is add labels on my graph, because graphs should always have labels. So I'm going to add a child node. I don't know what, I'm just going to do I'm not even going to try to organize this. I'm just going to add a label. And the text of this label is going to be ball velocity. And let's see if I can make it larger. Text, align, vrep, autorep, clip text, uppercase. Well, let's just move it over here and see if it's visible. Move it up a bit. Move it over to there. Let's see if I can give it a color. I don't actually know how to give a text a color. Maybe I'll skip that for now. I am going to give this name x-axis. I'll duplicate it. So now we also have something called y-axis, which I will call count. And I'll move that over there, kind of like that. But it's not showing. Maybe if I try rerunning it. That's interesting. So maybe what, oh, we lost one. 99 balls present. Let's see. I'm thinking about what to show next. While I'm thinking, I'm going to adjust the position of this Y label a little bit. So I learned something about the engine just now, because I created Y-axis, but it didn't appear in this game until I closed and restarted the game. But if you have something that's already created and you update it, like with an exclamation point, that might be kind of small and hard to see. But it does update it. All right, any questions either from the chat or the phone call? I'm interested both in the, for me, hypnotic nature of the visual changes, as well as the fact that I can demonstrate something out of a physics textbook on this thing. It's called the Maxwell bolt. This time it's still about the graph. The question was, what's the physics thing that's being shown? And it's the fact that the graph has this nice shape. Not that nice of a shape sometimes because it's a little noisy. So, question from the phone call, do the people watching know how to use this engine Godot? If you're here and lurking, I'd love to hear from you in the chat and say if you have any experience using Godot or either that or other programming environments. Meanwhile, I'm watching the timer and it's almost out of time on this 30-minute thing, so I'm about to go to the BRB screen. In fact, I'll jump there early. BRB screen. Oh, off the rails gaming coming in with a save. Your audio isn't working. Can only hear music, no voice. Oh man. Thank you for that, off the rails gaming. I've actually got to jump to BRB mode though right now. Off the rails gaming says can hear you now. Okay, that's good. Okay, I'll be right back. Okay, what are we doing? I'm gonna grab some screen caps from this. Is there a file? I want to export just this, the one. Oh, I can move this thing. Okay, cool. Well, then I'll just do it this way. I'm not exactly sure what I'm going to do with these shots, but I think they might make a good blog post. So I'm going to save them. Probably a better way of doing this. And I'm sure for my viewers this is about as good as watching paint dry. Let's not forget to do a 30-minute timer, although I may take a break before the end of that to eat something. Oh, the velocity is moving faster now per scene, per pixel of the video. Oh, wow. That's interesting. Here's where it wrecks the velocity distribution. Just flattens it. I'm still audible now, right? Yeah, I'm definitely. My audio is going out there. Oh, and then I added another bunch. Oh, look at that. That is so fascinating. I don't know if anyone else would find this as fascinating as I do, but I am like seriously geeking out. Let's analyze. Go back. It flattens out. Then as they spread out, it's more concentrated over here. Then they fall back down. It's like it's bouncing. Forward, backward. Let's, oh, oops. Right, this is a video. Let's play it again. How do I slow things down? What if I change it to GLS2? Changing the video driver requires restarting the editor. Save and restart. I'm curious if I can distribute this on the web. That is so cool. It's like the whole thing is bouncing. That is so interesting. Let's let this run for a while I have a bite to eat. remember to turn my mic on. Yeah, that sets them off bouncing. So does dropping a bunch of balls in the middle of them. I think it's unavoidable. Oh, there goes one. Down to $7.99. Nice. I'm not into this track. Okay, well, we're on to the next one. I think that's a better spot for the mic. Oh, pardon that, I bumped the mic. Maybe that's a better spot for the mic. Hey, Raphael. Ciao Raphael asks, what's the idea behind all those balls? Well, the idea is I was working through a Godot tutorial where, just to show the basic capabilities of the game, it had you create 6 balls and watch them bounce around. And I thought, well, 6 balls is fun, but how about 1,000 balls? And they're they're rigid spherical bodies, and all they do is bounce around. But the cool thing is, oh, there goes one. You see that, like, what are some things we can watch them do? I can drop them all the way down here. I'll drop some more. And look at that spike in the velocity. That is like one of my favorite things about this. But you'll notice that although I've dropped all of them at a lower level than the walls of the cage, eventually, if I put enough in, some of them are going to bounce out and escape. I had another 100. And I predict that we'll lose some now. Almost lost one there. Oh, there goes one. There goes one. Raphael says, that's a weird behave. What's weird about it? I thought they would go into inertia at some point, after some point. Going into rest, I mean. Yeah, I'm not sure how realistic the physics is here. I haven't thought about it in those terms. And you're right, with friction, if the friction is 1. You know, this is interesting. I hadn't thought about that. What if we set the bounce down to 0? What does it look like? This is actually more like a solid. Let's absorbent. Okay, turn that on and see how they do. Let's give them a little more bounce. You can see crystal structures forming when I turn the bounce way down. That is neat. What's the typical bounce? The typical bounce is 0. What's that about? What if I turn them to rough? Let's start this over. What if the bounce is at 1, but they're still absorbent? This velocity graph is not very meaningful right now. Let's turn off absorbent. Raphael says, I think absorbent makes it so that the ball is not bounceable. So here it says, property absorbent. If true, subtracts the bounciness from the colliding object's bounciness instead of adding it. If they're absorbent, they go still really quickly. If they're non-absorbent, I mean, that has to do with whether it's elastic or inelastic collisions, if I'm remembering my physics. Friction doesn't seem to make a difference one way or the other. Or maybe it does. What about static? Oh, wow. That's weird. Totally different behaviors from the different types. Character, kinematic. What does rough do? It has to do with which friction it uses. Raphael says static and kinematic is configurable with scripts, if I'm not mistaken. Sure. Should be configurable with scripts. I think just about everything is. Oops, sorry about that bump to the mic. Lost a bunch of them to that when you give them low mass. Raphael, what's the difference between static and kinematic? Let's bring the weight back down to something more basic. Mass and weight. Set the friction down and they jump around a lot more. I'll hold shift for more precise changes. That's interesting. Why can't I set absorbent to be like somewhere in between? I love how that one little one just goes in circles. That one too. Look at that defect migrating through the crystal. And those. Whoa! This is some cool dynamics. You got an empty spot there. It's like a tower of them. Oh man, if I turn off absorbent, it's gonna be crazy. question is, do they calm down over time? Or does the bounciness give them some kind of, like, perpetual motion machine stuff? What is the normal bounce? Normal bounce is 0. Well, with 0 bounce, they just collapse. I wonder what bounce means for the object. Whoa, weird. They're like overlapping each other. This is strange. This doesn't seem like the right physics, but it's fun. Turn absorbent back on. Oh, weird, and now they're expanding again. Why would that be the case? That doesn't make sense to me. Turn up the bounce. Let's start it over again. Gotta say, that looks more realistic than the crazy bouncing, but it's a lot less fun. Why is there always one down here that's spinning? Bounce seems to make them spontaneously jump. Almost like they're floating. You can see these ones around here are starting to go. Maybe the ones underneath them will start to go soon. Okay, time for a stream break. Let's get that BRB screen. I should be muting my mic when I do this. Okay, be back soon. Let's see, is my mic on? Yes, it is. That's good. Where is this in terms of Git? Diff. Guess I'm going to commit this cleanup. What's I gonna do? Yeah, I was gonna go back to the tutorial. Where was I? Captain Foodbar says, hey, how are you today? Hi. I'm doing well today. Godot adventure continue? Yep. Yeah, I'm continuing with Godot. I noticed kind of a cool thing that I can do if I go to QuickTime Player. I don't know why I don't have it open. Let me find it. So I saved a video. Turn the volume down on it. Notice the video quality is kind of horrendous. But I've got this vertical spike in velocity that you see as the balls accelerate downwards. They start with 0 velocity, and then their velocity goes up until it's about around 100, or maybe this is 75 here. See, and then they fall down and they accelerate, and then it's off the chart for a while, and then they hit everything else, and it throws off the velocities completely. And it kind of bounces. See, it's this shape, and then it flattens out, and then it's back to more of this shape. More flattens out. Captain Fubar asks, do you teach? Not formally. I want to get into making more educational content. If you know someone who would like to learn on stream, I think that'd be kind of cool. Send them my way. There it is, bouncing again. You can see the line going from side to side. Captain Fubar says the curve seems to have more resolution. You know, it does have more resolution. Interestingly, it's time resolution that's the difference. You can especially tell if I play it at full speed. It's moving a lot faster, and it visually averages out those kinks that you saw before. Captain Fubar asks, did you increase the velocity intervals? I did not increase the velocity intervals. I changed the time of how frequently it was calculated. So previously, if I go to Godot main, where's main? Script. I had this at 50. If print counter greater than 50, and print counter was going up by 1 every time. But I just took that out, so now every frame of process draws this, calculates, and sets my node2.poolVector2Array to ARR. So that's the difference that I made. Anyway, I was thinking I would continue on with the tutorial here. This is where I just was. Imagine we started creating the room. We could make a couple of different room scenes with unique arrangements of furniture in them. Later we could make a house scene that uses multiple room instances for the interior. We would create a citadel out of many instance houses. Many instance houses and a large terrain on which we would place the citadel. Each of these would be a scene instancing one or more sub-scenes. Later we could create scenes representing guards and add them to the citadel. They would be indirectly added to the overall game world. With Godot, it's easy to iterate on your game like this. All you need to do is create and instantiate more scenes. We designed the editor to be accessible to programmers, designers, and artists alike. A typical team development process can involve 2D or 3D artists, level designers, game designers, and animators all working with the Godot editor. Summary. Instancing the process of producing an object from a blueprint has many handy uses. With scenes, it gives you the ability to divide your game into reusable components, a tool to structure and encapsulate complex systems, a language to think about your game project's structure in a natural way. Scripting languages. I think I can probably safely skip this one, but maybe it's worth doing. This lesson will give you an overview of the available scripting languages in Godot. You will learn the pros and cons of each option. In the next part, you will write your first script using Godot script. Scripts attached to a node and extended behavior. Captain Foobar says at least you can skim through it. Yeah, skimming through it is a good idea. Scripts attached to a node and extend its behavior. This means that scripts inherit all functions and properties of the node they attach to. That's interesting. For example, take a game where camera 2D node follows a ship. The camera 2D node follows its parent by default. Imagine you want the camera to shake when the player takes damage. As this feature is not built in Godot, you would attach a script to the camera 2D node and code the shake. Available scripting language. Schooly B says yo yo. Hi Schooly B, thanks for stopping by. Let me show you the cool thing that I'm kind of happy with having made. Why does QuickTime Player keep quitting? That's fine whenever I drop some things. Check out this vertical spike in the velocity, because all of these balls that are dropping have the same velocity because they're in free fall and they're accelerating according to gravity. Schooly B says, tagged you in something on Twitter earlier, hope that's alright. Yeah, that's fine. Thank you. I like the attention. Schooly B says, how's it going? It's going okay. I'm glad you stopped by. It's nice to have some more company. Right, the thing that I was going to show is how ball velocity on the horizontal and count on the vertical shows that when I drop a bunch of balls, their velocity goes like that, and they go down and they go up, and the velocity plot follows like that, and I think that's really cool. And let's leave that open because I might be wanting it for later. Anyway, what I'm doing now is going through the Godot tutorials. Godot offers 5 gameplay programming languages: Godot Script, C#, Visual Script, and, via its GD native technology, C and C++. Schoolaby says, pretty cool, thumbs up. Thank you, I'm glad you like it. You can use multiple languages in a single project. For example, in a team, you could code gameplay logic in GD Script as it's fast to write, let level designers script quests in the graphical language Visual Script, and use C# or C++ to implement complex algorithms and maximize their performance. Or you can write everything in GD Script or C#. It's your call. We provide the flexibility to answer the needs of different game projects and developers. Warning: Godot 4.0 will remove Visual Script from core entirely. As a result, creating new projects using visual scripting in Godot is not recommended. Future Godot 4.x releases may have Visual Script re-implemented as an extension. We recommend trying out GD Script. Which language should I use? If you're a beginner, we recommend to start with GD Script. We made this language specifically for Godot and the needs of game developers. It has a lightweight and straightforward syntax and provides the tightest integration with Godot. Alright, I'm sold. For C#, you will need an external code editor like VS Code or Visual Studio. Interesting. GD Script is an object-oriented and imperative programming language built for Godot. It's made for and by game developers to save you time coding games. Its features include a simple syntax that leads to short files, blazing fast compilation and loading times, that's nice. Is it a compiled language? Must be. Tight editor integration with code completion for nodes, signals, and more information from the scene it's attached to. Built-in vector and transform types, making it efficient for heavy use of linear algebra, a must for games. Supports multiple threads as efficiently as statically typed languages. Is it not a statically typed language? No garbage collection, as this feature eventually gets in the way when creating games. The engine counts references and manages the memory for you in most cases by default, but you can also control memory if you need to. Gradual typing. Variables have dynamic types by default, but you can also use type hints for strong type checks. Captain Fubar says you can statically type if you want. Okay, that's good to know. Squirrel. GDScript looks like Python as you structure your code blocks using indentations, but it doesn't work the same way in practice. It's inspired by multiple languages, including Squirrel, Lua, and Python. Note, why don't we use Python or Lua directly? Years ago, Godot used Python, then Lua. Both languages' integration took a lot of work and had severe limitations. For example, threading support was a big challenge with Python. Developing a dedicated language doesn't take us more work, and we can tailor it to game developers' needs. We're now working on performance optimizations and features that would have been difficult to offer with third-party languages. .NET C#, I'm going to skip. C#, note you must use. Okay, C#. Since Godot uses the mono.NET runtime in theory, you can, okay, well, whatever. Note, Godot script itself doesn't execute as fast as compiled C# or C++. However, most script code calls functions written with fast algorithms and C++ code inside the engine. In many cases, writing gameplay logic in Godot script, C# or C++ won't have a significant impact on performance. Visual Script, Godot 4.0 will remove Visual Script from core entirely, we saw that. C and C++ native. You can use any version of the language or mixed compiler branded versions for the generated shared libraries thanks to our use of an internal C API bridge. That sounds a little scary. Okay. GD Native is the best choice for performance. You don't need to use it throughout an entire game, and you can write other parts in GD script. Summary. Scripts are files containing code that you attach to a node to extend its functionality. Godot supports 5 official scripting languages. You can mix languages, for instance. Okay. Creating your first script. Hey, look at him go. Whee! In this lesson, you will code your first script to make the Godot icon turn in circles using GD script. As mentioned in the introduction, we assume you have programming foundations. The equivalent C# code has been included in another tab for convenience. See more to learn more about GDScript, its keywords, and its syntax sent to this Godot reference, Godot script reference. I'll look at that later. Project setup. Please create a new project to start with a clean slate. This is first script. Okay. We're gonna save. We're gonna quit to project list. Open project manager, yes. First script. New project. Captain Foobar says, side note, if you choose to statically type, you get a little more performance out of your code. That's good to know. First, I'll name it this way. Users, Eric Anderson, workspace, Godot, create folder, create and edit. We need to create a sprite node to display it in the game. Your project should contain one picture of the Godot icon, which we often use for prototyping in the community. We need to create a sprite node to display it in the game. In the scene, click the Other Node button. Other Node. Type sprite in the search bar to filter nodes and double-click on sprite to create the node. Double-click on sprite to create the node. Your scene tab should now only have a sprite node. Got it. A sprite needs a texture to display. In the inspector on the right, you can see that the texture property says empty. To display the Godot icon, click and drag the file icon.png from the file system dock to the texture slot. There's texture, there's icon.png. There we can drag it. Neat. Note, you can create sprite nodes automatically by dragging and dropping images on the viewport. Oh, that's nice. Then click and drag the icon in the viewport to center it in the game view. Okay, let's zoom in. Center it in the viewport. Okay. To create and attach a new scripture node, right-click on the sprite in the screen dock and click Attach Script. Attach Script. Change the template from default to empty to start with a clean file. Leave the other options by default and click the Create button to create a script. Warning, having the script name be the same as a built-in type is usually not desired. Well, I'm going to assume it is desired in this special case. Extends sprite. The script workspace should appear with your sprite.gd file open and the following line of code, extends sprite. Every GD script file is implicitly a class. The extends keyword defines the class the script inherits or extends. Well, which is it, inherit or extend? In this case, it's sprite, meaning our script will get access to all the properties and functions of the sprite node, including classes it extends, like node 2D, canvas item, and node. Note, in GDScript, if you omit the line with the extends keyword, your class will implicitly extend reference, which Godot uses to manage your application's memory. Inherited properties include the ones you can see in the inspector dock, like our node's texture. Texture. Note, by default, the inspector displays the node's properties in title case, capitalized word separated by space. In GDScript code, these properties are in snake case, which is lowercase word separated by an underscore. You can hover any properties name in the inspector to see a description and its identifier in code. Hello world. Our script currently doesn't do anything. Let's make it print the text hello world to the output bottom panel to get started. Add the following code to your script, func init print hello world. Func, is it underscore init? Yeah. Save sprite.tscn, sure. Let's break it down. The func keyword defines a new function named init. This is a special name for our class's constructor. The engine calls init on every object or node upon creating it in memory if you define this function. Note, GDScript is an indent-based language. The tab at the start of the line that says print is necessary for code to work. If you omit it or don't indent a line correctly, the editor will highlight it in red and display the following error message: indented block expected. Save the scene if you haven't already, then press F6, Command R on macOS to run it. Look at the output bottom panel that expands. It should display Hello World. Okay, run. Command R. There it goes. Hello World. Delete the init function so you're only left with the line extends sprite. Okay. Turning around. It's time to make our node move and rotate. To do so, we're going to add two member variables to our script: the movement speed in pixels per second and the angular speed in radians per second. Okay, var speed equals 400. Var angular speed equals pi. Note, angles in Godot work in radians by default, but you have built-in functions and properties available if you prefer to calculate angles in degrees instead. To move our icon, we need to update its position and rotation every frame in the game loop. We can use the underscore process virtual function of the node class. What's a virtual function? If you define it in any class that extends the node class like sprite, Godot will call the function every frame and pass it an argument named delta, the time elapsed since the last frame. Note, games work by rendering many images per second, each called a frame, and they do so in a loop. We measure the rate at which a game produces images in frames per second, FPS. Most games aim for 60 frames per second, although you might find figures like 30 frames per second on slower mobile devices, or 90 to 240 for virtual reality games. 240 frames per second, wow. The engine and game developers do their best to update the game world and render images at a constant time interval, but there are always small variations in frame render times. That's why the engine provides us with this delta time value, making our motion independent of our frame rate. So at the bottom of the script, define the function func process delta rotation plus equals angular speed times delta. Captain Fubar says, a virtual function is a lifecycle function of the game engine that can be overridden by you. Okay, yeah, that makes sense. Where was I? Func process. Delta rotation plus equals speed. We haven't defined rotation. Maybe we don't have to define rotation. Maybe it's a property of something. Node 2D has a rotation property. Huh. Nice. That's useful to know. The func keyword defines a new function after we have to write the function's name and arguments that it takes in parenthesis. A colon ends this definition, and the indented blocks that follow are the function's content or instructions. Captain Fubar says, some of these are init, ready, enter tree, process, physics process, exit tree, notification, etc. Okay, good to know. Note. Notice how underscore process, like underscore init, starts with a leading underscore. By convention, Godot's virtual functions, that is to say built-in functions you can override to communicate with the engine, start with an underscore. The line inside the function rotation plus equal angular speed times delta increments our sprite's rotation every frame. Here, rotation is a property inherited from the class nodeTD, which sprite extends. It controls the rotation of our node and works with radians. Tip: in the code editor, you can control-click on any built-in property or function like rotation, position, or process to open the corresponding documentation in a new tab. Run the scene to see the Godot icon turn in place. Okay. Select current scene, sure. Yeah, look at it go. That's nice. Moving forward, let's now make the node move. Add the following two lines to the process function, ensuring the new lines are indented in the same way as the ones before them. bar velocity equals vector dot up dot rotated rotation times speed. What is speed? Oh, okay. Bar velocity, we'll do this bit by bit, equals vector 2 dot up dot rotated rotation, not rotated, rotated of rotation times speed. What's going wrong? Oh, bar velocity equals Captain Foobar, vector 2 dot up equal vector 2 of minus 1, 0. Oh! Cool. Up unit vector, y is down in 2D, so this vector points minus y. Captain Foobar says, I am wrong, vector 2 dot up equal vector 2 paren 0 comma minus 1. Right, because y is the second one. But I got the idea of what you were saying. Position plus equals velocity times delta. Huh. This is so smooth to write. Captain Foobar says x equals 0 and y equals minus 1. Yeah, that sounds right. Okay, as we already saw, the var keyword defines a new variable. If you put it at the top of the script, it defines a property of the class. Inside of a function, it defines a local variable. It only exists within the function's scope. We define a local variable named velocity, a 2D vector representing both the direction and the speed. It's interesting that if position is how come velocity position is a property, but velocity is not a property? That's kind of interesting to me. We define a local variable named velocity, a 2D vector representing both a... Captain Foobar says vector 2 has the equivalent other direction constants, vector 2 dot down, vector 2 dot right, and vector 2 dot left. Right, I kind of saw those in the documentation. Left, right, up, and down. And they're all unit vectors. We also have a 1 vector, a 0 vector. Interesting. Okay, moving on. Velocity is a 2D vector representing both the direction and the speed. To make the node move upward, we start from the vector2 class's constant vector2.up, a vector pointing up, and rotating it by calling the vector2.rotate method. This expression, vector2.up.rotated of rotation, is a vector pointing forward relative to our icon. Multiplied by our speed property, it gives us a velocity we can use to move the node forward. We add velocity times delta to the node's position to move it. The position itself is of type vector2, a built-in type in Godot representing a 2D vector. Run the scene to see Godot head run in circles. Neat. Whee, look at it go! Pretty cool. Now, can I... what if I export... Yes, I can. So, let's move this over here. And move this over here. And I can increase the speed. Uh-oh. But the speed also, you know what, it's the angular speed that I wanted to play with. It's in a tighter... Captain Fubar says, tip, you can set the debug window to always be on top in the project settings. Oh, this debug window. That would be a nice thing. Project settings. See if I can find that. I'll see if I can find debugs, window settings. Display window. Okay. Display window. Async enabled, energy saving, keep screen on. Mode disabled, aspect, hide home indicator. Always on top. Always on top. Do I have to save or do I just close it? Yeah, there we go. Look at it spin. That's fun. Whee! Oops, I didn't mean... Wait a second. 400 actually doesn't make it go that much faster. 40 does. This is silly. What about 100? Oh, it's actually going too fast now. I see. It's flipping out. It's going all over the place. I think I broke it. Okay. Set you back to your normal speed. That was fun. Alright, where were we? We had velocity times delta to the node's position to move it. The position itself is a type vector 2D, a built-in type representing a 2D vector. Oh, run the scene to see Godot head run in circles. Yeah, I saw that. No, moving a node like that does not take into account colliding with walls or the floor. In your first 2D game, you will learn another approach to moving objects while detecting collisions. The node currently moves by itself. In the next part, listening to player input will use player input to control it. Complete script. Here is the complete sprite.gd file for reference. Cool. Oh, and there's the timer. So let's go to BRB mode. Now how do I do that? Just like that. Okay, let's move on to the next section, which is listening to player input. Building upon the previous lesson, creating your first script, let's look at another important feature of any game, giving control to the player. To add this, we need to modify our sprite.gd code. You have two main tools to process the player's input in Godot. The main input callbacks, mainly onhandled input, like underscore process. It's a built-in virtual function that Godot calls every time the player presses a key. It's the tool you want to use to react to events that don't happen every frame, like pressing space to jump. To learn more about callbacks, see using input event. We'll open that up for later and place it right next to here. The input singleton. A singleton is a globally accessible object. Godot provides access to several in scripts. It's the right tool to check for input every frame. We're going to use the input singleton here as we need to know if the player wants to turn or move every frame. For turning, we should use a new variable, direction. In our underscore process function, replace the rotation plus equal angular speed times delta line with the code below. Okay, var direction equals replace rotation equals angular speed plus delta. Rotation plus equal angular speed times delta. Delete that. Replace it with var direction equals 0. If input.isActionPressed UI left, if input.isActionPressed UI quote UI left cool colon direction minus equal direction equal -1. If direction.action pressed UI right direction equal 1. If input.isAction is no, not just pressed. UI right. Also this I don't want to be just here. Direction equal 1. Rotation plus equal angular speed times direction times delta. Angular speed times direction times delta. Our direction local variable is a multiplier representing the direction in which the player wants to turn. A value of 0 means the player isn't pressing the left or right arrow key. A value of 1 means the player wants to turn right, and -1 means they want to turn left. To produce these values, we introduce the conditions and the use of input. A condition starts with the if keyword in GD script and ends with a colon. The condition is the expression between the keyword and the end of the line. To check if a key was pressed this frame, we call input.isActionPressed. The method takes a text string representing an input action and returns true if the action is pressed, false otherwise. The two actions we use above, UI left and UI right, are predefined in every Godot project. They respectively trigger when the player presses the left and right arrows on the keyboard or left and right on a gamepad's D-pad. Note, you can see and edit input actions in your project by going to Project Settings, and clicking on the Input Map tab. Finally, we use the direction as a multiplier when we update the node's rotation. Rotation plus equal angular speed times direction times delta. If you run the scene with this code, the icon should rotate when you press left and right. Save, run. Whoa. Oh, it's always moving forward? That's tricky. Huh. Whee! It's kind of fun. Now what if I change the angular speed here while this is going? Well, oh, I lost it. Okay, never mind. Moving when pressing up. To only move when pressing a key, we need to modify the code that calculates the velocity. Replace the line starting with bar velocity with the code below. Var velocity equals vector2.0. Vector2.0. If input.isActionPressed UI up, if input.isActionPressed of up, quote up, UI up, velocity equal vector2.up.rotated rotation times speed. So that one went over my head. This might be my last session for tonight. Velocity equals vector2.up.rotated of rotation. Up.rotated of rotation. times speed. Okay. We initialize the velocity vector with the value of velocity2.0, a third constant of the built-in vector type representing a 2D vector of length 0. If the player presses the UI up action, we then update the velocity's value, causing the sprite to move forward. Here's the complete sprite.gd file for reference. Yeah, it looks about right. If you run the scene, you should now be able to rotate with the left and right arrow and move forward by pressing up. Let's try it. Oh, I didn't do something right. Okay, let's see what I can debug. Bar velocity is vector2, oops. Vector2 dot up. Dot rotated, rotation times speed. Okay, now let's try it. I think I like making games. Gonna clip that. Okay. Making figure eights and then standing still and going in circles. Yay. It's fun. It's easy to do. I hope I didn't get lost. Okay, I'm good. Can't go backwards though. Wonder if it'll implement that next. Summary. Let's if input dot is been pressed, UI up. Oops, I want UI down. Velocity equals vector2 dot up. No dot. Can I just do down? Dot rotated. Will this be the right direction? I'm not sure if this is gonna work out right, but I'm gonna try it. I don't feel like thinking through the geometry. Okay, that's good. Summary. In summary, every script in Godot represents a class and extends one of the engine's built-in classes. The node types your classes inherit from give you access to properties like rotation and position in our sprite's case. You can also inherit many functions which we didn't get to use in this example. Right on. In GDScript, the variables you put at the top of the file are your class's properties, also called member variables. Besides variables, you can define functions, which for the most part will be your class's methods. Godot provides several virtual functions you can define to connect your class with the engine. These include process to apply changes to the node every frame, and onhandled input to receive input events like the key and button presses from users. There are quite a few more. The input singleton allows you to react to players' input anywhere in your code. In particular, you'll get to use it in the process loop. In the next lesson, using signals, we'll build upon the relationship between scripts and nodes by having our nodes trigger code in scripts. Okay, that sounds good. is coupling? In software engineering, coupling is the degree of interdependence between software modules, a measure of how closely connected two routines or modules are. The strength of the relationship between modules. Coupling is usually contrasted with cohesion. Low coupling often correlates with high cohesion. This is too theoretical for right now. Oh wow, I've been at this for 3 hours. How did that happen? Sammy is here. Hello, Sammy. Do you want to get in my way? Or do you just want to drink my water? I'm not gonna let you drink my water. Will you stand up if I try to make you stand up for it? Let's put you on the screen, kitty. See if we can do that. No, don't drink my water. Are you drinking my water? You're certainly trying to. He's drinking my water. There he goes. Thirsty kitty. How about that? Here, I'm gonna put this down for you, Sammy. You can go drink all you want. I'll get myself a new cup of water. He's still going and he's in the way of my keyboard. Did you have enough, Sammy? Nope. Still going for more. Silly kitty. Alright, Sam, you're getting picked up. You're going on screen. Here's Sammy. He doesn't want to be on the camera very much. That's what you get when you come and try to steal my wallet. Now I'm thirsty. Ah. Yeah. That was a cat interlude. Hey, Musubi no Kami. Thank you for that follow. I feel like I didn't do much during that follow. I've just been kind of vibing here, but maybe that's okay. How are you doing? What's your night like? I forgot I'm not going to drink this water because Sammy got into it. Well, let's learn about signals in Godot. Using signals, in this lesson, we will look at signals. They are messages that nodes emit when something specific happens to them, like a button being pressed. Other nodes can connect to that signal and call a function when the event occurs. Signals are a delegation mechanism built into Godot that allows one game object to react to a change in another without them referencing one another. Using signals limits coupling and keeps your code flexible. For example, you might have a life bar on the screen that represents the player's health. When the player takes damage or uses a healing potion, you want the bar to reflect the change. To do so, in Godot, you would use signals. Note, as mentioned in the introduction, signals are Godot's version of the observer pattern. You can learn more about it here, Game Programming Patterns, observer.html. Open that for later. We will now use a signal to make our Godot icon from the previous lesson, listening to single player input, move and stop by pressing a button. Scene setup. To add a button to the game, we will create a new main scene, which will include both a button and the sprite.tscn scene that we scripted in the previous lessons. Create a new scene by going to the menu Scene, New Scene. Scene, New Scene. In the scene dock, click the 2D scene button. This will add a node 2D as our root. Node 2D. Good deal. In the file system dock, click and drag the sprite.tscn file you saved previously onto the node 2D to instantiate it. Sprite.tscn, drag it onto there. There it is. We want to add another node as a sibling of the sprite. To do so, right-click on node 2D and select Add Child Node. Search for the button node type and add it. Add child node button. Create. The node is very small by default. Click and drag on the bottom right handle of the bottom in the viewport to resize it. 2D, it is small. How do I need this mode of touching it. Make it bigger, that might be too big. If you don't see the handles, ensure the select tool is active in the toolbar. Boom, select tool. Click and drag the button itself to move it closer to the sprite. Closer to the sprite. You can also write a label on the button by editing its text property in the inspector. Enter toggle motion. Text. Toggle motion. Okay. Your scene tree and viewport should look like this. Sprite, button, button, sprite. Sprite, button, button, sprite. Okay, cool. Save your newly created scene. You can then run it with F6. At this moment, the button will be visible, but nothing will happen if you press it. Save node 2D, sure. I'm not going to bother running it. Connecting a signal in the editor. Here we want to connect the button's press signal to our sprite, and we want to call a new function that will toggle its motion on and off. We need to have a script attached to the sprite node, which we do from the previous lesson. You can connect signals in the node dock. Select the button, and on the right side of the editor, click on the tab named Node next to the inspector. Click on the button, Node. Oh, look at that. The dock displays a list of signals available on the selected node. Double-click the press signal to open the node connection window. There you can connect the signal to the sprite node. The node needs a receiver method, a function that Godot will call when the button emits the signal. The editor generates one for you. By convention, we name these callback methods on node name, signal name. Here it'll be on button pressed. Button connecting from to sprite. On button pressed, connect. On button pressed. That's so easy. Note, when connecting signals via the editor's node dock, you can use two modes. The simple one only allows you to connect to nodes that have a script attached to them and creates a new callback function on them. The advanced view lets you connect to any node and any built-in function, add arguments to the callback and set options. You can toggle the mode in the Windows bottom right by clicking the advanced function. Don't need to do that right now. Click the connect button to complete the signal connection and jump to the script workspace. You should see the new method with a connection icon in the left margin. Oh yeah. Source button, signal pressed, target sprite. Okay, what happens if I delete this?
At the first stroke, it will be 10, 4, precisely.
If you click on the icon, a window pops up and displays information about the connection. This feature is only available when connecting nodes in the editor. Let's replace the line with the pass keyword with code that'll toggle the node's motion. Our sprite moved thanks to code in the process function. Godot provides a method to toggle processing on and off node.setProcess. Another method of the node class, isProcessing, returns true if idle processing is active. We can use the not keyword to invert the value. Wait a second. I think I need to read that again to understand it. Our sprite moves thanks to code in the process function. Godot provides a method to toggle processing on and off, node.setProcess. Another method of the node class, isProcessing, returns true if idle processing is active. What's idle processing? Anyway, we can use the not keyword to invert the value. Set process parens not is processing. So we're inverting the is processing thing. This function will toggle processing and in turn the icon's motion on and off upon pressing the button. Before trying the game, we need to simplify our process function to remove the node automatically and not wait for user input. Replace it with the following code, which we saw 2 lessons ago. Func. This is node. Sprite. We want sprite. Oh, we're already there. Rotation plus equal angular speed times delta. Rotation plus equal. Important difference. Bar velocity equals vector 2 dot up. Rotated. Yeah, I'm gonna deal with that lower stuff later. Position plus equal velocity times delta. Just delete all this stuff. It's not worth much. Your complete sprite code should look like the following. Okay. Run the scene and click the button to see the sprite start and stop. Where's my button? Oh, I need main. No, I still don't have it. Oops, come back. Where is it? Why don't I see my button? This is a weird problem. I feel like I'm only playing the sprite. There it goes. So I guess this sprite was set as the main scene. That's what was going wrong. How do I set something new as the main scene? We'll worry about that later. Connecting a signal via code. You can connect signals via code instead of using the editor. This is necessary when you create nodes or instantiate scenes inside of a script. Let's use a different node here. Godot has a timer node that's useful to implement skill cooldown times, weapon reloading, and more. Head back to the 2D workspace. You can click 2D to text at the top of the window, or press Ctrl F1, Alt F1, Alt 1 on Mac OS. In the scene dock, right-click on the sprite node and add a new child node. Search for timer and add the corresponding node. Your scene should now look like this. Add child node, timer. Yep, oh, sprite. Timer should be under sprite. Okay, it should look like that. With the timer node selected, go to the inspector and check auto start property. Timer auto start on. Check the script. Click the script icon next to sprite to jump back to the scripting workspace. Script icon next to sprite scripting workspace. We need to do two operations to connect the nodes via code. One, get a reference to the timer from the sprite. Two, call the timer's connect method. No, to connect a signal via code, you need to call the connect method of the node you want to listen to. In this case, we want to listen to the timer's timeout signal. We want to connect the signal when the scene is instantiated, and we can do that using the node.isReady built-in function, which is called automatically by the engine when a node is fully instantiated. To get a reference to a node relative to the current one, we use the method node.getNode. We can store the reference in a variable. So we're in sprite var timer equal get node timer. Func ready var timer equal get node quote timer. Good. The function getNode looks at the sprite's children and gets nodes by their name. For example, if you rename the timer node to blinking timer in the editor, you would have to change the code to get node blinking timer. Okay. We can now connect the timer to the sprite in the ready function. Func ready timer.connect timeout self on timer timeout. Timer.connect timeout self on timer on capital timer timeout. The line reads like so. We connect the timer's timeout signal to the node which the script is attached, self. When the timer emits timeout, we want to call the function onTimerTimeout that we need to define. Let's add it to the bottom of our script and use it to toggle our sprite's visibility. Func onTimerTimeout visible equal not visible. The visible property is a boolean that controls the visibility of our node. The line visible equal not visible toggles the value. If visible is true, it becomes false and vice versa. If you run the scene now, you will see that the sprite blinks on and off at 1 second intervals. Complete script. Let's run it and see that it actually works. We want to go to node 2, run scene. Hey, it disappears. What if I toggle motion while it's... Oh, wow. Ah! Cool. Okay. Custom signals. Note, this section is a reference on how to define and use your own signals and does not build upon the project created in previous lessons. You can define custom signals in a script. Say for example, you want to show a game over screen when the player's health reaches 0. To do so, you could define a signal named died or health depleted when their health reaches 0. GD script extends node TD signal health depleted var health equal 10. As signals represent events that just occurred, we generally use action verb in the past tense for their names. Your signals work the same way as built-in ones. They appear in the node tab and you can connect them like any other. To emit signals in your scripts, call emit signal. Func take damage, health minus equal amount if health less than 0, emit signal health depleted. A signal can optionally declare one or more arguments, specify the argument names between parentheses. Extends node signal health changed of old value new value. What does it mean for a signal to take arguments? Note, the signal arguments show up in the editor's node doc, and Godot can use them to generate callback functions for you. However, you can still emit any number of arguments when you emit signals, so it's up to you to emit the correct values. That went a little over my head, but let's keep going. To emit values along with the signal, add them as the extra arguments to the emit signal function. Emit signal health changed old health health. Okay. Summary. Any node in Godot emits signals when something specific happens to them. Hey, a few seconds ago, M Phantom has followed. Thanks for that, M Phantom. How are you doing tonight? Signals have many uses. With them, you can react to a node entering or exiting the game world, to a collision, to a character entering or leaving an area, to an element of the interface changing size, and much more. Whoa. Mr. Phantom coming in with the first time chat, I'm okay and you, but in all caps. That almost feels aggressive. But yeah, I'm okay. I've been streaming for about 3.5 hours, and I was thinking about calling it a night pretty soon, but maybe I've found a second wind, we'll see. For example, an area 2D representing a coin emits a body entered signal whenever the player's physics body enters its collision shape, allowing you to know when the player collected it. In the next section, your first 2D game, you'll create a complete 2D game and put everything you learned so far into practice. Okay, that's it for that section. For those of you in YouTube land, thanks for watching. Wait, I didn't stop. There it goes. What just came up on my phone? So many things are happening. Okay, M Phantom, what's your story? Are you interested in coding? Have you learned stuff about Godot before? I forget, I can look at the camera when I talk to you. It's tempting to look down at the chat window because that's where, the chat comes from. But the camera's up here, so if it looks like I'm looking at the camera, then it looks like I'm looking at you. Someone pointed that out to me today, that's a thing I can do, is focus on the camera when I'm responding to people. But that's it for that timer. So it's time to go into the BRB screen, but I'll be watching for a text if you want to say something, Phantom. BRB screen, here we go. Oh man, there goes the timer. Yeah, I think it's time to end the stream for tonight. I think that time has come. Thanks for watching. See you next time. Oh wait, let's maybe raid someone. Who's on? Only the Tricky channel. Maybe Sunday night is not really an active time for Twitch. Let's raid the Tricky channel with my one viewer. Let's do it. Okay, raid now. Again, thanks for watching. For those of you on YouTube, it's just going to end, but you can go watch the Tricky channel on Twitch if you want to.